Hello everyone, welcome to my channel. In today's industrial world, strength, precision, and durability are the foundation of every machine. Behind massive factories, towering steel structures, and heavy-duty equipment lies one critical engineering process that holds everything together: welding. Welding engineering is not just about joining metal parts. It is about creating strength, safety, and long-lasting performance in industrial machines. Advanced welding engineering has transformed how industries build, repair, and maintain machinery, making modern production faster, stronger, and more reliable than ever before. Industrial machines operate under extreme conditions. They face high pressure, intense heat, constant vibration, and heavy loads. To survive and perform efficiently, every joint and connection must be flawless. This is where advanced welding engineering plays a vital role. Through innovation, skill, and technology, welding engineers ensure that industrial machines can withstand harsh environments and continue operating without failure. Welding engineering combines science, technology, and hands-on skill. It involves understanding materials, heat behavior, joint design, and mechanical stress. In industrial machines, welding is not a simple task. Every weld must meet strict quality standards because even a small defect can lead to machine failure, production loss, or safety hazards. Advanced welding techniques have been developed to meet these challenges and push industrial engineering to a higher level. At the heart of welding engineering lies material science. Industrial machines are made from various metals such as carbon steel, stainless steel, aluminum, and special alloys. Each material reacts differently to heat and pressure. Advanced welding engineering focuses on selecting the right welding method for each material. Engineers carefully analyze the metal's properties to prevent cracks, distortion, and weakness. This scientific approach ensures that welded joints are as strong as, or even stronger than, the base metal itself. One of the most important aspects of advanced welding engineering is precision. Industrial machines require exact alignment and accuracy. Even a slight misalignment can affect performance and efficiency. Advanced welding methods allow engineers to control heat input, penetration depth, and joint geometry with high accuracy. This level of control reduces material waste and improves the overall quality of the machine. Modern industrial welding has moved far beyond traditional manual techniques. Today, advanced welding engineering uses automated and robotic systems. These systems provide consistent quality and speed, especially in large-scale industrial production. Robotic welding machines can perform repetitive tasks with extreme accuracy, ensuring uniform welds across multiple components. This not only increases productivity, but also minimizes human error. Automation in welding engineering has revolutionized industrial machine manufacturing. Computer-controlled welding systems allow engineers to program specific welding parameters such as voltage, current, and speed. These systems adapt in real time to changes in material thickness or joint conditions. As a result, industrial machines are built with higher reliability and reduced production time. Advanced welding engineering also plays a crucial role in heavy machinery fabrication. Machines such as hydraulic presses, cranes, turbines, and industrial conveyors rely heavily on welded structures. These machines handle enormous loads and operate continuously. Welding engineers design joints that distribute stress evenly and prevent fatigue failure. Through advanced joint design and testing, engineers ensure that machines remain safe and operational for years. Another key area of advanced welding engineering is quality control. Industrial welding requires strict inspection and testing procedures. Engineers use non-destructive testing methods such as ultrasonic testing, radiographic testing, and magnetic particle inspection to detect internal and surface defects. These techniques allow engineers to identify problems without damaging the machine. Quality control ensures that every weld meets international safety and engineering standards. Heat management is another critical factor in advanced welding engineering. Excessive heat can weaken metal, cause distortion, or create residual stress. Welding engineers carefully control heat input to maintain the structural integrity of industrial machines. Advanced techniques such as pulse welding and controlled cooling help minimize thermal damage. This results in stronger, more stable machine components. Safety is a top priority in welding engineering. Industrial machines are often used in environments where failure can cause serious accidents. Advanced welding engineering reduces the risk of failure by ensuring proper weld strength and consistency. Engineers follow strict safety protocols and standards to protect both machines and workers. High-quality welding contributes directly to workplace safety and operational reliability. Maintenance and repair of industrial machines also depend heavily on advanced welding engineering. Over time, machines experience wear and tear. Instead of replacing entire components, welding engineers can repair damaged parts through advanced welding techniques. This saves time, reduces costs, and extends the lifespan of industrial equipment. Precision repair welding restores strength without compromising machine performance. Advanced welding engineering also supports innovation in industrial design. Engineers can create complex machine structures that were not possible with traditional joining methods. Lightweight yet strong designs improve efficiency and reduce energy consumption. Welding engineers collaborate with mechanical designers to develop machines that are both powerful and economical. Environmental sustainability is becoming increasingly important in modern industry. Advanced welding engineering contributes to sustainability by reducing material waste and energy consumption. Efficient welding techniques minimize rework and scrap. Automated systems optimize energy use, making industrial production more environmentally friendly. Welding engineers play a key role in building sustainable industrial solutions. Training and skill development are essential in advanced welding engineering. Industrial welding requires highly skilled professionals who understand both theory and practice. Welding engineers and technicians undergo extensive training to master advanced equipment and techniques. Continuous learning ensures that they stay updated with new technologies and industry standards. Advanced welding engineering is also essential in critical industries such as power generation, construction, oil and gas, and manufacturing. Industrial machines used in these sectors must meet the highest quality requirements. Welding engineers work under strict regulations to ensure reliability and safety. Their expertise supports the infrastructure that drives modern economies. In industrial machine manufacturing, time is money. Advanced welding engineering increases production efficiency by reducing downtime and defects. Faster welding processes and automated systems allow manufacturers to meet tight deadlines without sacrificing quality. This competitive advantage is crucial in today's fast-paced industrial market. The future of welding engineering in industrial machines looks promising. Emerging technologies such as artificial intelligence, smart sensors, and real-time monitoring systems are further improving welding accuracy and efficiency. These technologies allow machines to self-adjust and detect issues during the welding process. Advanced welding engineering continues to evolve, pushing industrial capabilities to new heights. In conclusion, advanced welding engineering is the backbone of industrial machines. It combines science, technology, and skill to create strong, reliable, and efficient machinery. From heavy-duty fabrication to precision manufacturing, welding engineering ensures that industrial machines perform under extreme conditions. It enhances safety, reduces costs, and supports innovation across industries. Industrial machines are not just built, they are engineered with precision and strength. Behind every powerful machine lies the expertise of welding engineers who transform raw metal into functional, durable structures. Advanced welding engineering is not only shaping machines, it is shaping the future of industry itself.